benchmarking is, what benchmarking is, and what reverse engineering is. Can somebody say what benchmarking is? Yes? Is benchmarking setting up standards? Competitive benchmarking? Good that you have come up to that. Competitive benchmarking is positioning my product vis-a-vis my competitors, and many times benchmarking refers to setting up a target. Okay, so some ideal level that is to be attained, or something that must be reached. Okay, similarly, reverse engineering. Can you tell me briefly what reverse engineering is? We discussed in the previous class. Feel free.
The product we are
beautiful. You have said it. What is it?
From the product we are going to the design system.
Beautiful. That's the essence of reverse engineering. Generally, from the design you realize a product. But on the other hand, from the product, if you want to go back to the design, that is the reverse thing happening. Okay. So this is how I couldn't open the pen and then show you the ball. She wouldn't let me do that. Okay. And I promised that I'll take a photograph and show you. This is the photograph taken in our lab. This is the photograph of a ballpoint pen taken in our previous slide. This is the photograph of the ballpoint pen taken in our metrology lab. I was not happy with the clarity. In fact, the person, the lab senior technician in the metrology lab, he was not happy with the image. Of course, we have capability to do much better job. There was some handicap and time pressures. We can take a much better image with facilities available in our lab. So to compensate, what he did was he tried to download something, and then he gave me, Mr. Tamil Chelvan, he gave me the figure. Next slide please. So this is a typical. We can even get better pictures with our system. So we can even get better pictures with our system. So this is the tip of a ballpoint pen. You can very clearly see the ball. So there must be a continuous flow of ink to the ball, which gathers the ink, and then subsequently it is going to be transferred to the paper. In fact, Mr. Tamil Chelvan took some more initiative. I didn't ask him to do it, in fact, but he downloaded a drawing of the cross section. Next slide please. So probably he wanted to show you this. So this is the cross section of the tip. You can see a ball. This is the ball, and you can see this is a local reservoir. So if the ink flow must be made continuously available to the ball, which means you must have a local reservoir. So this is the area earmarked for the local reservoir, and this is how the ink comes in. Okay, and this ball, there are many tricky issues. This ball should neither come out, at the same time it should freely rotate. Okay, how we are going to achieve that? Again, okay, some good engineering has to go into it. If you want to really ensure that the ball doesn't come out, at the same time it freely rotates inside. How I am going to assemble all that, that is where real engineering comes into play. Okay. Now, this is what I wanted to say regarding value. In what context do we discuss this? Can somebody give me a word or phrase? What is SOP? Subtract and operate. Do you appreciate the idea of subtract and operate? Why should I do subtract and operate? Yes? To appreciate the real significance of a particular part, okay, I subtract it and then operate it. After I gave the assignment, I wanted to caution, this operate is done virtually. I mean, in your imagination. Okay? Please don't subtract any part and operate it in real life. Because I gave some potentially dangerous assignments also. For example, plug, okay, socket, tester, okay. I don't know, tester has a very important component in it. If you subtract that and then operate, it may lead to fatal accidents. Can somebody tell me what that component is?
Body.
A tester, a simple electrical tester, it has one important component. If I subtract and operate, yes?
Spring.
But
Plastic.
no. I don't know, I should not be helping you out in your assignments also. Because those who got the tester assignment will get an undue advantage.
So the end of the plastic, sir. Spring.
Huh?
At the back of the tester,
Huh?
was the hand.
The tester works fine. That is one important part. If you remove that and then operate, I don't know. Okay, I'll probably discuss it when we discuss the assignments. Okay, so when I say subtract and operate, you must operate it in your mind. Okay, don't remove the ball from the fan and then operate it. No, operating doesn't mean switching on the fan and then seeing it flying off. No. What you have to do is, imagine that you have removed the ball, and if the fan tries to rotate, then what will happen? You understand the idea? Okay. Now I think it is time we move on to the agenda we have for today. Today we are going to talk about market opportunity analysis. If you recall our scheme of things, this is the second step in our design process. We have told you the first steps. I would have given you a big flow chart in the first lecture. Okay, so there are 12 steps essentially involved. The second step is, the first step is to have a vision. Vision for approaching the existing problem in a new fashion. There are many tools which help us in directing or in channelizing our vision. One such tool is the S-curves of various products. So the second step is the market opportunity analysis. Now, whenever we think of a product, okay, we operate under two major risks. Next slide. When we talk of any product, we work under two types of risks. One is a technical risk, the other one is a market risk. What is the technical risk? The technical risk is, can I really make this particular product? When Wright brothers thought of developing an aeroplane, okay, the big question before them is, can I make something that flies? Okay, when Watt was bent on developing something which will produce mechanical power. Before James Watt, the power, the only energy source that man can tap on is either from nature or from the muscular power of biological systems. I can walk because my muscle is able to extract some. That is the only source of power known to man. Plus natural sources of power like wind or falling water. So the only power known to human being before the invention of a steam engine, okay, where the muscular power and the powers available in nature. People know how to use a bullock or an ox for doing some job. People long before Industrial Revolution knew that. But they are all sources of, what is the power source in all these cases? The muscular power or the power available in nature. People used windmills and water mills, everything was there. But a new system which will develop mechanical power, okay. So James Watt was attempting that, and the big task before him was whether I could succeed generating mechanical power from steel. Whether I could succeed. So the biggest challenge before developing any product is, can I achieve it technically? This is the biggest question that you must address whenever you venture into developing a new product. Can I really realize the product technically? Okay, be it anything, be it a cell phone or whatever is the product, be it a computer, be it a laptop. Can I achieve it technically? So any new venture, it has its own associated risks. If there is no risk, there is nothing new in it. So any new venture has its own associated technical risk. So the first question is, can we really make it? That is the technical risk part of it. Is that the only risk that a product development engineer must handle? No. There is another important risk, an equally important risk, because by our definition of product itself, product is something which is meant for market. It is not meant for my personal consumption. If you are developing a toy for your kid brother or a kid sister, that is not a product in true sense of the word. You understand? You develop a simple toy for your kid brother, that is really not a product. Product is something which enters into market. Am I explaining that convincingly? Product is something which is meant for market. So what is the associated risk? When I design something new, will somebody bother to buy it? Will they care to buy it? Will my potential customer buy my product that I am designing? This is another risk, that a product, if it is to succeed, it should address both these risks. One, I must be able to make it. Number two, I must make it in such a way that my customers will buy it. Then only any product will succeed. Is it clear? So for any product to succeed, it must address the twin issues. What are they? Technically it should be possible. I should not imagine later on, probably after another 6 lectures, I will be talking to you about one of my pet subjects. It is on perpetual motion machines. Okay? When we are talking about new concepts, I will be talking about perpetual motion machines. Perpetual motion machines are, as the name itself indicates, machines that move forever. Okay? That is, all that I need to do is, I should start that machine, it will be going on, running. It will run perpetually, forever. So these machines were, many great people were involved in designing perpetual motion machines. B.S.ABDUR, the great Indian mathematician, he was involved. He designed a perpetual motion machine. Leonardo da Vinci, he was a great engineer. He designed a perpetual motion machine. Please remember, these perpetual motion machines can never be technically realized. These are machines which will not work. But as I will show you later, they are so beautiful. It appears as if I put little more effort, I will make this work. Believe me, many engineers and scientists committed suicide because they couldn't realize a perpetual motion machine. I'll talk later about it. Okay. The point I'm trying to impress upon you now is, technically it should be possible for you to realize it. A perpetual motion machine can never be realized. Okay. Even a conceivable, even a system which is not a perpetual motion machine, it will pose you a lot of technical challenges, and these issues are to be successfully addressed before you overcome the technical risks. Now, of course, there are many other issues. There are issues of time. Okay? There is no point in saying that my company has developed a digital density of so many transistors per square centimeter. Okay? When somebody has done 10 times that already. In technological development, the time factor is always important. Now I cannot say that I will develop a new cell phone with touch screen and all that which weighs just 250 grams. People will laugh at me. They say already commercial systems are available at less than 125 grams. Why are you talking about a weight which is 2 times that? So, at every point of time when you develop a product, the time factor is important. And then there are many other factors, but the major issues are the technical feasibility and the market feasibility. Next slide please. Now, what are the tools with which I can mitigate these risks? These risks do exist. All that I can do is, I can approach these risks in a prepared way. See, I repeatedly say this, some of you may even get bored about this statement, but it is very important. All that we are learning in this paper are the various tools that enable us to do product design in a scientific way. Please believe me, great people, they don't work in a very scientific way. Great people have their own ways of doing and then inventing things. Do you understand? Edison didn't study a paper on product design and then get patent for more than 1,000 products. The problem is, all of us are not Edisons. But still, we have to design a product. That is why we have to study a paper on product design. If inventing new products is left to the genius characters, then many of the new products will not come at all today. So, all that we are trying to learn in this particular paper is, what are the scientific tools, scientific methods by which I can approach product design. Do you understand? See, in product teardown, we have talked about one way of appreciating what product design is. One tool that is available for us is subtract and operate procedure. That is one technique with which you can appreciate the need for individual parts. Like this, here today, we are going to talk essentially about 3 different tools. The 3 tools are technical questioning and mission statement, business case analysis, identifying the design drivers. This is all that I am going to teach today. I am going to teach about the 3 tools that are useful in identifying the technical risks and the market risks. Okay, let us take them one by one. Let us first take the technical questioning. I will not give an introduction to each. Okay, we will see them in detail. Let us first take the technical questioning and mission statement. Right. Next slide please. Technical question. There are a series of questions. This is not a complete list. Now at the beginning itself, I would like to tell you, these questions are to be raised and answered by the design team at every stage of the design process. As many times you raise this question, it is better for your design. At every stage, you raise these set of questions and then try to get the answer. Now, what is the objective? Before we go into the details of what these questions are, what is the basic spirit behind technical question? Okay. The spirit behind technical question is, are we addressing the question, are we addressing the design issue at the right level, or should we go deeper and look into the problem? That is why many of the systems fail. Many product development ventures, they fail because they took something for granted and tried to develop something. Let me explain what I mean by this. Suppose I presume that the maximum density that can be achieved in an integrated circuit is so much. Then I try to develop an IC which will have more computational power. I will actually fail. I should come one step down. I should come one step down and then address the problem. Okay, let me take a simpler example. Okay. Suppose I say that the efficiency of my petrol engine is going to be 65%. I take it for granted. And then design a car which will have extra mileage. Can I do it? I can do it to some extent. I can reduce weight of the vehicle, try to gain something on the mileage. I can do many other things. But see, the improvement that I achieve will only be marginal. When I presume that, I am not going to touch my engine. The engine is going to give me only 65% efficiency. I am not going to touch that at all. But I am going to, what is my design challenge? What is my technical challenge? I will design an automobile, a car with increased mileage. Can I do it? Yes, I can do it. But only in a limited way, only in a small way. I can reduce the weight and try to improve the mileage. I can modify some peripherals here and there. I can improve the mileage. But to get better mileage, where should I attack? I should attack at the engine efficiency first. Because that is the fundamental level. Whether I am missing such fundamentals in a design process, in this case it is so obvious. But many times, certain problems will not be so obvious. So the technical questioning is meant to identify whether I am attacking at the correct level. Okay, let us go to the questions first. What is the problem really about? What is that I want to achieve by this particular product? So what is the problem all about? Many times it is said that if you rightly put the problem, if you rightly pose the problem, that is more than solving it. That is almost solving it. If I pose the problem correctly, okay, you are very close to solving it. Many times the solution is elusive. We are not able to get the solution because we don't pose the problem in a correct way. On a lighter side, let me take an example. Okay. Now, a student is coming late. None of you guys. A student is coming late to the class. I am asking, why are you late? No, such things will never happen with you guys. But if somebody comes late, I am asking him, why are you late? He will say, the bus is late, sir. Okay. Now, the thing is, I should again probe, why the bus came late? No, I missed the right bus. I got the next bus only, so I came late. Now the probing has to go many steps down to really make the student appreciate that the problem is not with the bus, the problem is with himself. Okay, I woke up late, that will never come as a first answer. Many times it doesn't come. Okay. Now the thing is, the problem needs to be stated very explicitly. Anywhere. Be it in solving our personal issues or be it in addressing a design problem. First of all, you need to state the problem in very clear-cut terms. That helps a lot in addressing the problem and solving it. In a very clear-cut terms, the problem needs to be posed. That is very essential in truly addressing the technical risks. What implicit expectations and desires are involved? See, the customer has many explicit expectations, but what is difficult to fulfill or even understand is the implicit expectations of a customer. What is explicit and what is implicit? Okay, but not exact. No, I won't call it as major and minor. Literally, what does something explicit means? What does something implicit means? Pardon?
Various other things.
Yes. Direct, indirect, okay, but not very good.
Not only one purpose, many purposes.
Yes,
Many purposes.
that is true, but what is an explicit expectation? What is an explicit expectation is something obvious. Or closer than direct and indirect, but not enough. Explicit is something obvious, something very outstated, which is very obvious. Okay, a pen is meant for writing. This is an explicit expectation. Pen is meant for writing. Pen is also meant for scratching my back. This is an implicit expectation, an implicit use. Okay, I use my pen to scratch my neck. Okay, that is not so good, but an implicit expectation. Okay, I am just trying to explain the term. Okay, now similarly, every product, okay, must have an explicit expectation and implicit expectation. Explicit expectations are easy to identify. You can always satisfy them. Okay, if you take an automobile, what is an explicit expectation? Mileage, comfort, pickup. These are all things that I can understand. But why certain brands click and why certain things don't? Because, see, people are attracted more by aesthetics. Aesthetics is an implicit expectation. I want my car to look beautiful. But what is beautiful, nobody knows. You understand? I want my car to look very beautiful, very appealing to me. But what is appealing? How can you define something appealing? Naturally, you will definitely buy a car which appeals to you. Yes or no? You will buy a cell phone which really appeals to you. See, the technical characteristics of the cell phone, I can express it in numbers. I can express what is the signal strength. Okay, I can give some number to it. Because the signal strength depends on, okay, the capability of the receiver I have. Any cell phone has a transmitter receiver. It has a transmitter receiver pair. It should be able to communicate with the nearest tower. Okay, which will in turn send it to the satellite. So the communication to the nearest tower depends on the capacity of my transmitter receiver pair, which I can reduce it to a number. Okay, all the features my cell phone has, I can list it out. The battery life that it will have, these are all, I would say, explicit expectations of the customer. I can almost write down I can reduce them into quantifiable numbers. But still, certain cell phones click and then certain other models, they don't. Why? Because certain cell phone, they somehow appeal to the market. Aesthetic design, okay, you call it whatever. Okay. Weight. Weight is an explicit thing. But aesthetics, appeal, these are all something which are implicit expectations. And these are the expectations which are difficult to capture. These are the expectations which are difficult to fulfill. True with every product. But you must try to address these issues. Okay. So what are the implicit expectations and desires involved? This must always be addressed at every level. Now, all the stated customer needs, functional requirements and constraints, are they truly appropriate? Because in modern product design, there is a huge amount of work division involved. If you take a product development team, see a typical product development team for Ford, for developing a new model. Take it from me, no product development takes place for Ford in India. All the product developments for Ford, they take place either in US or in Australia. The entire Asia Pacific region, their product development is centered in Australia. For the entire Europe and US market, Ford does the product development in US. Is it okay? This is their organizational structure. I am taking this as an example. A typical product development team in Ford US will consist of, for a new automobile, it will consist of typically some 150 to 200 engineers. And believe me, there will be a lot of outsourcing involved in it. The engine design will not be done by Ford as such. They will outsource the entire engine design to someone else. What they will do is they will specify what are the expectations out of the engine and then give the task to someone else. So like this, we are going to have a huge amount of work division and in product development. So when such work division does exist, are the true customer needs, are they truly expressed? Are they appropriate? I must question them at every level. I should not, the very idea is something like this. I should not imagine a constraint and then start working within that constraint. So you question the constraints at every level and re-evaluate. Now, what avenues are open for creative design and inventive problem solving? See, any breakthrough in design comes out of what is popularly known as out-of-the-box thinking. That is a traditional way a problem is being addressed. Okay, but the real breakthroughs, they come by what is known as the out-of-the-box thinking. Okay, there is a routine way of solving the problem. There is a routine way of solving the problem. Now, the real breakthroughs, they come through by not just following the beaten track, but by going for some innovation, some out-of-the-box thinking. Now, am I closing the avenues for that? Am I really opening the scope for some real inventive, creative problem solving? Okay. Am I constraining it? Like the engine efficiency is going to be 65%. So that puts a full stop for any real breakthrough in enhancing the for any real breakthrough in enhancing the fuel consumption. So the basic problem is, are we keeping open all the avenues for real breakthrough? Next slide, please. Now at which are not possible which are not open really for the design. See, there are certain things which are not open for redesign or so there is one thing to keep open the real options for development, real options for breakthrough. But there is altogether another thing to keep on reinventing the wheel in the name of keeping everything open, in the name of keeping all the options open. I should not be reinventing the wheel. See, for example, suppose, let me take the same case of an automobile. Now I should not start designing the bearing. Okay, bearing is something which is which does take away some efficiency. There is friction in the bearing, so there is a frictional loss in the bearing. Okay, that frictional loss if we reduce, naturally my efficiency will improve, no doubt about it. But that is not my core competence. That is not my real capacity. My real capacity is designing somewhere else. Bearing is something well studied by somebody else. It is somebody's scope. Do you understand what I mean? Not that improvement in bearing is not important. Improvement in bearing is important, no doubt about it. But that is not in my scope. There are better people to do that job. So, what I do is, I say that this particular aspect of design is not in my scope. I say I am not going to redesign the bag. I am not going to redesign a bolt. There are companies exclusively involved in designing and making bolts. Do you know any company which is involved in making bolts and nuts? Yes? Bosch? No? Bosch has some other capability. No? They have some other capability. Fasteners. Now tell me. Bolts and nuts, the general name is fasteners. In Chennai, in Madurai. No. Rane is, they have some other capability.
So Lucas.
What is that exactly?
Lucas TVS.
Lucas TVS is not into brakes. A part of that group. But what is that company called? Sundaram Fasteners. They are manufacturers. They are one of the leading manufacturers. As a mechanical engineer, you should know all these things also. Sundaram Fasteners. They have their plant in Chennai and they have a huge facility in Madurai. They are, please believe me, an exclusive company employing more than 500 people involved in making bolts and nuts. So the entire company is meant for making various nuts and bolts. Employing more than 500 people. You should appreciate the significance. Don't belittle it. Okay. So suppose I cannot be redesigning my bolts and nuts. That should be done by somebody else. I should not venture into areas that are not my core competence. So that is what I mean by what avenues are limited and not open for creative design. I am not going to design the bolt. I am not going to design the bag. I will upfront say that my design team is not going to look into all these issues. Now the next thing, what characteristics and properties must the product have? So this is another important issue. What characteristics and properties must the product have? And what characteristics and properties my product must not have? Suppose I'm designing a cell phone which is meant for, say, economically conscious people. Okay, what he wants is that there is a segment in the market which wants to have a very cheap cell phone, and they are going to use the cell phone for only making phone calls. So in that cell phone, I should not think of introducing a camera or introducing a FM radio, okay, or introducing GPS or introducing, okay, so something else. So what is the objective? The objective is a low-cost cell phone which will be a bare minimum capabilities. So it will be meant for only communication. So I must decide upon, depending on the, later on we will be talking about what is known as a brand position. Every particular product is meant for a particular segment of the market. Later on we are going to see market is too general to be treated as a single entity. So I will segment the market and deal with it. This is called market segmentation. Okay. See, boys have a particular taste. Girls, they do have a separate taste. In the two-wheeler market, probably, I think a scooty was introduced, okay, which is primarily meant as a, right, is it scooty or something else? Which is primarily designed as a lady bike. Is it okay? The color, the appeal, the design, everything has to be done accordingly. So, bike is something which is meant for the youth. So, a 60-year-old or a 70-year-old man will never buy a bike. And no parent will permit her, and legally also it is not admissible that a kid buys a powered bike. Okay. So, a bike is meant for a particular market. What is that? Youth. Say age between, say, 18 to 35. Bike is something which is designed for. So then this is one segmentation of market. Then you subsequently divide it further for men, for women. So every product, please believe me, is meant for a particular segment of the product. If you see the advertisements, you will be able to easily identify what is the segment that a particular product is trying to catch. Certain products are meant for housewife. They are addressed to housewife. Certain products are meant for kids. Okay, they are addressed in the advertisements, right from the advertisement to product design to packaging, everything is tuned to appeal to a particular segment. Okay, so we are going to talk about this in detail, what is known as market segmentation. Market can be divided in many fashions. Based on sex, you can divide the market. Based on age, you can divide the market. Based on ethnicity, you can divide the market. Okay, what clicks in Tamil Nadu may not click in Bihar. Okay, so there are various ways by which the market can be segmented, and I must decide my product characteristics based on the segment of the market which I try to address. Is it okay? Next is, what aspects of the design task can and should be quantified now? Sorry. Every engineer, he or she wants to attribute a number finally. Because only when you quantify it, okay, our evaluation tend to be accurate. Okay, you will not be happy if I just say that your performance in the assignment is good. You will immediately ask me, sir, what is the mark? Isn't it? Why do you ask that? You want to have a number. Okay. So, quantifying something is also very, very important. Now, at every stage, quantifying also is a difficult task. So at every stage of design, quantifying means putting a full stop to it, giving a sort of finality to something. So at every stage of design, I must decide what I am freezing and what I am leaving open. Okay, what is frozen, what is fixed, what is decided, and what is left open for further improvement. Next slide, please. Now, do we have any? Always I should look at whether I am biased in any way. Whether I am biased, whether I am driven by some preconceived notion, which may be wrong. In which case, if I identify at some stage that my decision is preconceived and it is based on some wrong assumptions, what I have to do is I have to go one step back and then try to redefine the problem. Now, there are always technical and technological conflicts inherent in any design task. See, many times designing something good is defined as what is called a conflict management. There are opposing pulls. I want my cell phone to be cheaper, at the same time I want it to have maximum features. These are two opposing things. I want both the things achieved. So it is a sort of how much cheaper and how many features. So that is the trade-off that I have to make. So this conflict management, about this we will see later in the lecture. We have to address the issue of the conflict management in any design task also. Next slide, please. Now these are all the technical questioning. The technical questions I must address. And these questions enable me in two things. One, in really addressing the problem, in really solving the technical difficulties and overcoming through my product design. And number two, in appropriately positioning my product in the market so that the risks from the market side are also addressed. The next important tool that I must use to address these twin issues is what is called a mission statement. What is a mission statement? Mission statement is pure and simple. In this product design, what do I want to achieve? You explain in clear-cut terms from the following 8 aspects. What is that I want to achieve by designing this particular product? You make a very clear, unambiguous statement about this particular thing. Okay, that is called the mission statement. Now, what is the first step in the mission statement is a product description. What is the product description? What is that I want to achieve in this particular product? Number two, what is the business and humanitarian goals? What needs it is going to fulfill? Number three, who is going to be my primary market? Who is going to be my secondary market? There is, for every product, there is always a primary market. There is always a secondary market. For example, I'll try to give some examples so that you can understand it in concrete terms. Suppose noodles. You are designing, noodles. Who is your primary market?
China.
Yes?
China.
Children, kids. Kids are your primary market. Is it okay? Yes, sir? Any jokes there? I would also love to laugh. No. So if you are designing a product like noodles, the primary market are the kids. Who are the secondary markets? Secondary markets are office goers, software people. They don't have time. They want to have a quick meal. They can be your potential secondary market. You understand? So for every product, whatever you design, you must identify who is my primary market. My advertising, my product positioning, my product packaging, my product characteristics, everything must be attuned to my primary market and to some extent my secondary market. Okay. Now, then what are the assumptions that I make? Let us be very clear. What are the assumptions that I make in designing the product? So, for every product there are certain assumptions. Okay, well, what is the assumption inherent in designing a noodles? The first thing that comes to your mind, what is the first characteristic that it should have?
Non-sticky.
It is the easiness with which it can be made. Okay. So how do they position the product? How do they call it as? 3 minutes. Well, why? Because that is identified as the essential characteristics of the product. It is a 3 minutes noodles. Okay. Because that is what they try to project. So that is an essential characteristics that should not be lost. Okay, if I design a very tasty noodles that will take 30 minutes to manufacture, there won't be any takers. Okay, in 30 minutes a mother can produce a much more delicious food. Okay, so the assumption is, the inherent characteristics is, it should be fast in that particular product. Similarly, every product has an inherent characteristics. These are the assumptions. Who are all the stakeholders? For every product, there are many stakeholders. So a consumer is a stakeholder, government policy is a stakeholder, okay, and my competitors are stakeholders because I want to capture a market share, so my competitors will be stakeholders, so they must be identified. Now what are the avenues for creative design? I must see, if I am entering into the market, I am thinking of designing a new noodles. What are the avenues? Okay, there are already, what are the avenues for creative design? There are many constraints already existing. Already you have the 3 minutes time limit. Okay, so whatever I do, I have to operate within this set of constraints. So, what is the basic scope for the creative design that I must be able to identify? See, I cannot make noodles out of new material. The raw materials available are constrained. So, what are the things I can really play with? And I must identify a definite area wherein I can channel my creativity and then try to arrive at the design. Now, what are the limitations? What is the scope and what are the limitations? Okay, so these must be very categorically identified when you start venturing on. So this will clearly position your product, this is the market, and this is the technology, and enable you to mitigate the risks of the technological uncertainty and the market uncertainty. So, basically, where did we start? I'm sorry, I'm running out of time because I have to cover a few more important issues. Where did we start? We started with the two problems involved in product. One is the technical risk and the other one is the market. So we are into identifying tools with which I can face these challenges. The first tool that we have studied is the technical questioning. The questioning and the mission statement. Okay. Shall we go to the next tool? The next tool is next slide. Business case analysis. It is a more advanced technique. Here, the basic approach is, the basic philosophy is, every product development process is identified as a business proposition. Any new idea of a product development is identified as a business proposition. Now, you evaluate, you analyze that business proposition in detail. That is the whole approach. Now, it starts with, it is a series of steps. It starts with a problem statement. Okay. The problem statement can be like this. I want to make a noodles that can be made in 2 minutes and that is more nutritious. Okay. So, what do I try to address here? Generally, there is a concern, there is an idea that noodles are junk foods. Okay. So I want to design a product, in this case a fast food, that can be made in 2 minutes. Okay. And at the same time, that is nutritious. There is a lacuna in the market. What is the lacuna? The existing noodles are all junk foods. So I want to design a noodles that is faster as well as nutritious. So this is the problem statement. What is the assumption? Assumption is today's world is very fast moving. Okay, people don't have time to cook. At the same time, people are becoming more conscious about the health. They are more aware about the dangers of having junk food. Okay, so that is the assumption under which I dare to venture and design this particular product. Then there are major factors, minor factors. What are the major factors? There are certain gross imperatives. Like for example, this is a consumer product. Noodles is a consumer product. To exist in the market, I must have a minimum sales volume. A minimum sales volume is to be achieved. Otherwise, I cannot exist in market. I cannot say that I will make a turnover of 1 lakh rupees, and then I cannot call myself as a noodles manufacturer. Okay, I can have a small petty shop. That's all. So to exist as a player in the market, there are certain things that I must satisfy. So I must achieve a critical turnover of such and such thing. I must achieve a critical turnover of, say, 10 crore rupees within a period of 1 year. Within a period of 1 year, okay, within 1 year, I actually enter into market. I must achieve a minimum turnover of, say, 10 crores. This is a major factor. A gross factor. Or I I must have a major factor defined in terms of, I must achieve a market share of, say, 20% within 1 year. So I must have a market share of, so the characterization like this are in terms of major factors. Or I can define my major factor like I should have a nutrition value of so much. So much in terms of say vitamins, so much in terms of minerals. Okay. I don't know. In today's paper it was that Bill Gates, all of you might know, is running a huge foundation. Okay. One of the biggest objectives of that foundation for this financial year, can somebody say what it is? Earlier they were into attacking AIDS, fighting cancer. Okay, they channel huge amount of money. This year, Bill Gates Foundation is channelizing about $2 billion US. $2 billion US in a particular area. Can somebody say what it is? It is there in today's Hindu and it is there for, say, about a week. He went to Davos with particular thing in his hand, created a lot of controversy in press. He went to, I think, World Economic Forum meet with a particular item in his hand. Yes? Food security, okay, you have zeroed in, but on what? He went to the World Economic Forum meeting in Davos with particular thing in his hand. Can somebody say what it is? Sago. He went there, Maravali Kadanga theriyuvilla? Maravali Kadanga அவர் கையில் எடுத்துட்டு போனார் World Economic Forum meeting. You know what is So why? Because that is the staple food for most of Africa. You have to go through it. Today's Indo and there are a lot of internet going, because anything about Bill Gates must be available extensively in internet. What is their mission statement? They very clearly defined an 8-point formula in what are the issues that are to be addressed in, because this is the staple food for almost entire Africa. This Maravali Kadanga is the staple food for almost entire Africa, and its production is threatened by certain virus attack. Okay, and if the production is affected, that means that Africa is going to starve. It is one of the biggest threats of today's world. It is a very cheap man's food. And what are the challenges in that food? The challenges are, there are some 5-6 challenges. One is the food production itself is threatened by the virus attack. So you have to make the varieties more resistant to these virus attacks. Number one. Number two, primarily it is only a carbohydrate. So it may fill your stomach, it may prevent you from starving to death, but it may not provide you with the necessary nutrients. Okay, so you have to, whether genetically I could fortify it so that it has more vitamins and minerals, especially protein. It is very low in protein. It is almost carbohydrate. So whether I could improve the protein content, because that is the only food people are going to eat. Okay. See, the most of the world is like that today. They don't have sambar, rasam or vegetables. No. They just boil this and then eat. So in which case, whether the same food can be made more nutritious by adding the minerals and protein and vitamin content. Number two, what is the first thing? Making them more immune to the virus attack, the diseases. Number 2, making them more nutritious. Number 3 is inherently they contain some toxins, okay, which lead to certain, when consumed on regularly, they lead to certain diseases. Whether these toxin contents could be reduced. See, if you eat once in a while, it doesn't matter. But when that becomes your staple food, that the toxins will accumulate in your body and then give you problems. Whether the toxins available in sago, whether they could be reduced, that is the third thing. So these are the essential targets that the Bill Gates Foundation is setting, and they are ready to spend, please believe me, is up to $2 billion in one financial year in addressing these issues, because they have a huge financial, humanitarian implications. Because if the production goes down, the Africa is going to stop. If the virus attack, if it becomes more prevalent and if the production goes down, the whole Africa is going to stop. Okay. And unless you address the other issues, even though they eat, they are not going to be really healthy. So, what I am telling you is, you just specify what is expected out of the new product. The product is already existing. You are not going to redesign another food. No. But the existing product, okay, he is having a lot of lacuna. What are the 3 lacunas listed? Immunity from virus attack, making it more nutritious, and less toxic. Then some modification genetically could be done in these products so that they are more accessible. This is the problem statement that we are talking about. So you must make a very clear problem statement. The assumptions are involved. Okay, you say that this is going to be the staple food for Africa for some time. Because the economy is not going to change, no revolution is going to take place there. So people are going to depend on this particular food for some time to come. Under these conditions, what are we going to do? So what are the major factors, minor factors? What are the alternatives? So what are the alternatives available? So you analyze everything as a business proposition and you identify the various alternatives, you come out with a recommendation, okay, and that recommendation is implemented. This is how the whole design problem is approached. So that is the business case analysis method, and the next thing and the most important thing that we would like to see is what is known as a design driver. The third tool that we have to talk about today is on design drivers. The idea is, in any design, you have a series of decisions being made. And many times, one design decision, it drives others. And in design, you have to make many trade-offs and compromises. I'll elaborate what I mean by all this. And there is a need to optimize in any design process. There is a need to optimize in any design process. Now let me take an example and let us see what I mean by all these things. Let us take it as a whole package. Let's take everything together. in a context of a particular example and then see what we mean. Please listen carefully for next 15 minutes. I'll try to talk about the design drivers alone. Suppose say, I want to design an aircraft. I want to design an aircraft. Now what is the basic science behind it? The basic science behind any design is, see, I have a flying machine, okay. Of course, you'll be studying about it in your mechanics, and you may study about it. For aero students, many professors will talk about it in detail throughout your career. There are 4 forces involved in any aircraft design. Okay, can somebody name it?
Lift force,
Lift,
Thrust,
weight,
drag,
thrust,
drag.
Okay, there are basically 4 things involved in any aircraft. So there is something called a lift, there is something called a weight. When an aircraft is moving at constant velocity, it is cruising at a constant velocity, okay, the lift will be equal to the drag and the thrust, the lift will be equal to the weight, thank you for correcting me. The lift will be equal to the weight and the thrust will be equal to the drag. Is it okay? The thrust is produced by the engine, okay. The thrust is produced by the engine. Drag is is the resistance offered by the wind, by the air around for the movement of the aircraft. That is the drag. So the thrust, it tries to push the aircraft forward. The drag, it tries to pull it. So these two must balance. And the lift is produced by this peculiar cross section, okay, as this moves, okay. So there is a lift produced, okay. When it is cruising at a level, the lift produced should be equal to the weight. Okay. The more powerful, in fact, there is another beauty in this. There is a relationship between the lift and the thrust. The more you push forward, okay, the more will be the lift produced depending on the angle of attack. Now this is the basic technology behind it. Now to put it simply, the more powerful my engine is, I'll be able to produce more thrust and more lift. The more powerful my engine is, I'll be able to produce more thrust and more lift. The more powerful my engine is, I will make my weight also slightly more. So, I must make a trade-off, a balance between how powerful my engine and how powerful and the weight that I am going to have in my system. Is it okay? Now, let us take another case. Okay, if I make a commercial aircraft that can carry 10 people, can it be used as a mass transport aircraft? No. So my people carrying capacity of the aircraft must be increased. And what happens? When I increase the passenger carrying capacity, the weight will increase, the cost will increase. Okay. then can I say like this, for every passenger carrying capacity, I will have an associated cost, and that I must be able to sell in the market. So even in passenger aircraft, you might have heard about say 40 seaters, 50 seaters, 60 seaters, some 200 seaters, some 500 seaters. Okay, where the aircraft is meant for say intercontinental journey, the aircraft is meant for short trips between cities. So these are all issues of market position. Now what I want you to look at right now is, there are certain major trade-offs to be made while taking the macro level decision. When I take a particular decision, and that decision starts driving other subsequent decisions. For example, I consider all these factors, cost, market, everything, and then arrive at a gross design specification. That in turn starts deciding my subsequent steps. So one design decision, it leads to other decisions, and you need to optimize, and you need to enter into what is known as trade-offs and compromises. You need to do what is known as a trade-off and a compromise. To achieve something, okay, you lose something else. This is what I mean by trade-off. Suppose if you want to have say more mileage in my car, okay, if you want to have more mileage in my car, I must lose all the extra weight. The car must be made very light. In which case, very naturally, I will lose more on stability. The classic case is the Royal Enfield bike. Most of you would love to own a Royal Enfield bike. People used to say, who used to drive the Enfield will say, "Sir, I can travel 500 kilometers in this bike, sir. I will not feel any pain." Yes or no? Okay. Why? Because it is a very heavy machine. It has huge stability. Okay. So the passenger comfort, of course, you cannot even. The rider comfort is very good. It is so heavy, most of the shocks it will never reach you. It will be absorbed by many of the subsystems in between. But what is the cost? It will? The mileage will be so poor. So, well, what is that I am looking at? I am looking at a trade-off between a mileage and I'm looking at a trade-off between the mileage and the comfort. Similarly, if you take any automobile, see, for example, for enhancing the stability of an automobile, you take it as a rule. Stability of any system is high. Stability of any system is high when the center of gravity is close to the top. If I am standing and if somebody tries to push me down, he can do it easily. Yes or no? If you give me a punch, probably I will fall down. When I am sitting, pushing me down is relatively more difficult. Imagine I am sitting on the floor. Pushing me down is more difficult because my center of gravity is closer to the ground. I am more stable. am lying down, you cannot do anything to me because I am at the lowest level of my potential energy. You cannot disturb me much. Okay? Incidentally, that is why you feel more comfortable when you sit and much more comfortable when you lie down. Because your whole system is, please don't lie down now. Your whole system is brought to the lowest energy level. The potential energy is very minimal. Your whole system is brought down to a very low energy level. You are very comfortable. Okay, you are able to take rest at that particular posture. Now, so when the center of gravity is low, okay, your stability is high. When the center of gravity is relatively high, the stability is disturbed, but at the same time, from the vehicle design point of view, the maneuverability is easy. Now it is you are at your liberty to decide where to have your center of gravity of the vehicle. You can have either a Tata Indica or an SUV. Where is the center of gravity for a Tata Indica? It is very low. Please believe me, the vehicle is more stable, but the maneuverability of the vehicle is less. Take Scorpio. Where is the center of gravity, relatively speaking? It is higher or lower?
Higher.
Please tell me, is the center of gravity higher or lower?
Higher.
The maneuverability of the vehicle is very high. At the same time, the stability is low. You can see accidents in which the whole vehicle topples. Can you, I don't know. You must be knowing better. Have you ever seen a Indica toppling over? Relatively speaking. But a Scorpio toppling over will be more. Why? Because the center of gravity is high. I have but with Scorpio, I can do all sort of yes on the road. You can do because it is more maneuverable. I can maneuver it like anything. I can do yes on road. If there are two vehicles, I can go in between and then find my way. So this is a decision. This is what I mean by trade-off and compromise. There are many such decisions that you may have to make in your design process, and you may have to make these decisions very judiciously. You have to make all the design decisions. Every stage of your design process, you may have to achieve something and then lose something. You can achieve stability, but you lose maneuverability. You can achieve what is known as a good mileage, but at the same time you will be using the comfort. Okay, so these trade-offs are to be done very judicially in any design process, and that will finally determine your product characteristics. Is it clear? Any doubts you have? Any doubts that you would like to discuss? Thank you.